Alright, this is the second video for assignment 44, and we're going to be looking at the equal bases equal exponents, or the one-to-one property for exponentials. If b to the x is equal to b to the y, that is equivalent to saying that x is equal to y. So for example, if we wanted to solve 2 to the x plus 1 is equal to 4 to the 2x minus 3, the common base between 2 and 4 is 2. So 2 to the x plus 1 is equal to 4 to 2 squared. So we have 2 squared and then raised to the 2x minus 3. Recall that if you have b to the m raised to the n, you're going to multiply your exponents. That becomes b to the m times n. So 2 to the x plus 1 is equal to 2 to the 2 times 2x minus 3. Now you have equal bases, so now you can equate the exponents. So x plus 1 is equal to 2 times 2x minus 3. So now it's a basic linear equation. So you have x plus 1 is equal to 4x minus 6. Subtract x and add 6 to both sides of the equation, and we have 7 is equal to 3x. Divide both sides by 3, and we have 7/3 is equal to x. And so that is something you've been solving before. So what happens when we don't have equal bases? We'll show you an example or two of what happens there. So we're going to start off with saying that here's a logarithmic equation here. Log base b of x is equal to m. So log base x is equal to m. So we're going to rewrite that. Base is b, exponent is m, and that's equal to x. Alright, now what we're going to do is we're going to raise both sides of this equation to the nth power. Remember, if you have power to a power, you're going to multiply, so b to the m raised to the m is b to the m times n. That's equal to x to the n. Now we're going to rewrite this in logarithmic form. The base is b, the argument is going to be x to the n, and the exponent here is m times n. Now notice that m is equal to log base b of x. We're going to make that substitution. So log base b of x to the n is equal to, we're going to go ahead and write the n first, so there's the n, times m, which is log base b of x. Now this is going to allow us to solve for exponents. Notice that the n came down as a factor. And that's going to be very helpful for solving equations with exponentials, and you're trying to solve for an exponent, and specifically when we don't have equal bases. And we call this the power rule for logarithms. So let's go ahead and solve. Or we're going to give you the steps before we solve. So solve exponential equations, okay? With unequal bases, so there's no way we can get the same base. So let's start with isolating the exponential expression. Two, you're going to take, and you can actually use any log. I choose to use the natural log. So you're going to take the natural log of both sides and then use the power rule to bring down the exponent. And then you're going to solve. So let's do two examples here. So let's write out our directions again, our rough sketch of how we're going to solve. So let's solve 3 to the x plus 1 is equal to 7. 3 and 7, they're not like bases. There's nothing in common there. So we're going to take the natural log of both sides. Now you can use any log you want. You could use regular log base 10, any log you want of a valid base, but you want to probably use log or log on your calculator, base 10, or natural log, which is base e. Those are the two that I would prefer. I like to use natural log because it's less writing as well. Okay, so we take the natural log of both sides, and then we're going to apply the power rule, which brings down the exponent, which is x plus 1. Now it's a factor. And times the ln of 3, and that's equal to the ln of 7. Okay, ln of 3 is a number. We don't know exactly what it is. We want to leave it alone as ln3 because it's going to be a messy decimal. So now what we're going to do is we're going to do the distributive property. So we're going to do the natural log of 3 times x and also times 1. Okay, so x times natural log of 3 is x natural log of 3. And 1 times natural log of 3 is 1 natural log of 3, or just natural log of 3. And that's equal to the natural log of 7. Okay, this is no different than solving, let me choose a color that shows up a little bit better. This is no different than solving 5x plus 2 is equal to 11. What are you going to do? You're going to subtract 2 from both sides and then divide both sides by 5. So here, you're going to subtract the natural log of 3 from both sides of the equation. Natural log of 7 and natural log of 3, we haven't learned about how to combine them, so you're just going to leave them as they are. So we have x natural log of 3 is equal to the natural log of 7 minus the natural log of 3. And then x and the natural log of 3 are connected by multiplications. We're going to do the opposite operation. We're going to divide both sides by the natural log of 3. Okay, and so this is going to give us the exact answer of x is equal to the natural log of 7 minus the natural log of 3 all over the natural log of 3. Okay. All right, let's do one more example. And we're going to solve e to the 2x minus 1 is equal to 5. And then we're going to make a note here that if you have e raised to the ln of x, that was x, and you have the natural log of e to the x is equal to x, and those are your inverse properties, and so those are going to come into play here. The exponential is isolated, so we're going to go ahead and take the natural log of both sides, and then this property is actually going to come into play here. So this is even better than the last example because the natural log and e are inverses of each other. So the natural log of e to the 2x minus 1 is just 2x minus 1. That's equal to the natural log of 5. Okay. Now we're going to solve this like you would solve 2x minus 1 is equal to 5, for example. You're going to add 1 and divide by 2. But the natural log of 5 and the 1 are not exactly like terms, so we're going to leave them as they are. So you have 2x is equal to the natural log of 5 plus 1. And then you're going to divide both sides by 2. And so we have x is equal to the natural log of 5 plus 1 all over 2. And that's our exact answer. In the next video, we're going to do some applications, so some word problems. So if you're wanting some more examples of solving word problems, that's a good video for you. You're going to get to some more practice in solving exponential equations. So stay tuned for part 3.